Okay, so picture this. Your car needs, a tune-up. But instead of driving it to the mechanic, it's parked like a million miles away. That's the crazy situation we're dealing with when it comes to space telescopes. Like the James Webb. Sounds impossible, right? But, well, that's exactly what we're diving into today. How to service these amazing machines that are giving us, these just incredible views of the universe. And to help us unpack all of this, we've got some cutting-edge research from the University of Illinois Granger College of Engineering. They're tackling the mind-boggling task of figuring out how to keep these telescopes running smoothly, even though they're ridiculously far away.
Yeah, it's really amazing how these telescopes can just peer into the depths of space and reveal all these secrets of the cosmos,
Sure. Yeah.
But they're also incredibly delicate and expensive. So maintaining them isn't just, a good idea. It's crucial if we want to keep pushing the boundaries of space exploration.
So I guess to really understand the scale of this challenge, we need to sort of picture where these telescopes actually are. They're hanging out at a place called the Sun-Earth Lagrange point L2, which is, about 1 million miles from Earth. Could you maybe explain what makes this location so special for telescopes?
Sure. So imagine this cosmic dance between the sun and Earth, right, with gravity pulling in different directions. There are these special points where those forces balance out, creating a sort of gravitational sweet spot. That's what a Lagrange point is. And L2, this particular one, is perfect for telescopes like James Webb and Gaia because it allows them to stay in a stable position relative to Earth, making, long-term observations much easier.
Okay, that makes sense. But wouldn't sending a repair crew out there be a logistical nightmare? I mean, 1 million miles.
Oh, you're absolutely right. Traveling to L2 would take a lot of time, money, and resources.
Yeah.
But the scientific discoveries we're getting for these telescopes are just phenomenal. Think of it like venturing into uncharted territory and finding a treasure trove of knowledge.
Yeah.
The difficulty of getting there is definitely worth it.
Yeah, I'm starting to see why this is such a fascinating area of research. And speaking of telescopes at L2, there's the Gaia spacecraft, which has been diligently mapping the Milky Way for over a decade now. But it's running low on fuel. What happens when a telescope runs out of fuel, way out there?
Well, traditionally, that would be the end of the mission. But researchers are exploring these new ways to extend the lifespan of these valuable instruments. For Gaia, one researcher, Ruthvik Balmina, has come up with a really ingenious idea.
Okay, I'm all ears. What is it?
Imagine a spider-like attachment that could dock with Gaia and provide the fuel it needs to keep going. Giving it a lifeline without interfering with its observations. This kind of technology could be a game changer for future missions.
That's incredible. So we're potentially talking about extending the life of space telescopes, even if they're, millions of miles away. That's a huge shift from just accepting that they have a limited lifespan.
Exactly. It's a whole new way of thinking about space exploration, moving towards a more sustainable model. But there are other challenges to consider, too, like damage from micrometeorites. These tiny space bullets have already, dinged some of the James Webb's mirrors, which are, unshielded. And future telescopes are going to be even larger and more vulnerable.
Right. It makes sense that protecting these delicate instruments should be a top priority. I mean, you wouldn't just scrap a sports car because it ran out of gas, would you?
Absolutely. And that's another area where Bamina's research is crucial. Not only is he working on extending telescope lifespans, but also on safe proximity operations. In other words, how to get a servicing spacecraft close to a telescope without, accidentally causing more damage.
So we're talking about precision maneuvers on a cosmic scale. This all sounds incredibly delicate, almost like performing surgery in space.
That's a great analogy. You can't just send a spacecraft hurling towards a telescope, even with the best intentions. But that brings up another challenge. How do you get a servicing spacecraft to L2 without frying the telescope with its thrusters? Using them to slow down near a telescope would be, disastrous.
It does sound like a delicate balancing act. How do you approach a telescope without bumping into it, all while trying to maneuver 1 million miles away from Earth? What are the researchers proposing?
Well, this is where it gets really interesting. Another researcher on the team, Robin Woolens, has been mapping out these hidden highways in our solar system.
Hidden highways, what are those exactly?
Think of them as special routes through space that require very little fuel. These pathways take advantage of the gravitational forces of the sun and Earth, creating a natural network for spacecraft to travel efficiently.
So instead of blasting through space with powerful engines, we're harnessing the solar system's own, gravitational currents to navigate. That's pretty amazing.
Yeah, it opens up some fascinating possibilities for reaching L2 and other destinations in space.
So these hidden highways sound like a game changer for space travel, but how do we actually like chart a course through them? It seems like that would require some serious calculations.
You're right. It's not as simple as plugging an address into a GPS.
Yeah.
But that's where Alex Pasquarella comes in. He's a PhD student who's developed this novel technique for trajectory design. It sounds complicated, but basically he's combining two different fields, dynamical systems theory and optimal control theory, to find the most efficient routes for spacecraft.
Okay, that does sound a bit complex. Could you break that down for us a little? Like, what do those theories actually mean in practice?
So imagine you're trying to find the best route from point A to point B on a map. But instead of roads, you have these like intricate gravitational pathways. Pasquarella's approach is like using a supercomputer to sift through thousands of possible routes, finding the ones that pass close to the target telescope, and then, optimizing those paths to use the least amount of fuel and time.
So it's like finding the most scenic route to L2, but for spacecraft. It sounds like this research is opening up some truly exciting possibilities. But where does it all stand right now? Are there any, like, concrete plans for servicing these telescopes?
Well, the plan to refuel Gaia is pretty much ready to go. The design is complete, and it could be implemented relatively soon if all goes well.
That's fantastic. It sounds like Gaia might get a new lease on life after all. But what about the James Webb? Is there a plan in place for its long-term maintenance?
The James Webb plan is still in development. It needs a bit more time in the workshop, so to speak. But the progress they've made so far is really encouraging.
It sounds like the future of space telescopes is looking brighter than ever thanks to this incredible research.
I completely agree. And what's especially exciting is that this is just the beginning. There's so much more to explore and discover when it comes to servicing these incredible machines that are expanding our understanding of the universe.
This is definitely a deep dive I won't soon forget. I can't wait to see what the future holds for space telescope servicing and the incredible discoveries that will come with it. We'll continue this conversation after a quick break, so stay tuned.
It's amazing to think that we might actually be like entering an era where we can extend the lifespan of space telescopes indefinitely. What are the broader implications of that, do you think? Well, what's fascinating here is that this research is forcing us to rethink our entire approach to space exploration. For decades, we've treated space as this, harsh, unforgiving environment where our missions had a limited lifespan. But now we're starting to see it as a place where we can actually like build and maintain a long-term presence. It's a fundamental shift in our thinking,
It's like we're moving from a disposable model to a sustainable one, which has huge implications for the cost of space exploration too, right?
Exactly. Imagine being able to like get 20, 30, even 40 years of science out of a single telescope. That would just, dramatically reduce the cost per year of operation, allowing us to invest in even more ambitious missions. It would be a game changer for the field.
I'm curious to hear more about the safe proximity operations you mentioned earlier. It sounds like that's one of the biggest challenges in servicing telescopes that are, millions of miles away.
You're right. It's a crucial aspect. We can't just like rely on the same brute force methods we've used in the past. Approaching a telescope in space requires a delicate touch, almost like performing surgery with a robot from a million miles away.
Yeah, I can see how that would require some incredibly sophisticated technology. What are some of the key advancements that are making this kind of precision possible?
Well, one of the most exciting areas is the development of, artificial intelligence and machine learning algorithms that can control the movements of servicing spacecraft with like incredible precision. These algorithms can take into account all sorts of factors like the gravitational pull of the sun and Earth, the position of the telescope, and even the tiny forces exerted by sunlight.
So it's like having a super smart autopilot that can navigate the intricacies of space and guide the servicing spacecraft safely to its target.
Yeah. Exactly. And these algorithms are constantly learning and improving as they, gather more data.
Yeah.
It's a remarkable example of how technology is enabling us to push the boundaries of what's possible in space.
So we've talked a lot about the technical challenges of servicing space telescopes, but what about the human element? What kind of skills and expertise are needed to pull off these kinds of missions?
That's a great question. It really requires a multidisciplinary team, with expertise in everything from astrophysics and engineering to robotics and computer science. You need people who can design and build the spacecraft, develop the software, plan the trajectories, and operate the robotic arms with incredible precision.
It sounds like it takes a village or maybe even a small city to service a space telescope a million miles away.
That's a great way to put it. And it's not just about technical skills. You also need people who are creative problem solvers who can think outside the box and come up with solutions to unexpected challenges.
It's like the ultimate team project, but with stakes that are much higher than just getting a good grade.
Exactly. And that's one of the things that makes this field so exciting. It's pushing the boundaries of human ingenuity and collaboration.
Speaking of collaboration, you mentioned earlier the potential for international partnerships in space telescope servicing. Could you elaborate on that a bit?
Well, this kind of undertaking is so complex and resource intensive that it really demands a global effort.
Yeah.
No single nation has all the expertise and resources needed to do it alone. International collaboration allows us to pool our knowledge, share the costs, and achieve something truly remarkable together.
It's like the ultimate expression of human unity, working together to explore the cosmos and expand our understanding of the universe.
I couldn't agree more. And it's not just about scientific advancement. International collaboration in space exploration can also foster diplomatic relations and promote peace among nations.
It's a reminder that we're all in this together, sharing this incredible planet and gazing up at the same stars.
Beautifully said. And it's not just about the big flagship telescopes like James Webb and Gaia. There are dozens of other space telescopes out there, both old and new, that are contributing valuable data to our understanding of the universe.
So this research has the potential to benefit the entire field of space astronomy, not just a few select missions.
Precisely. And that's what makes it so exciting. We're not just talking about fixing individual telescopes. We're talking about developing a comprehensive approach to space telescope servicing that can be applied across the board. It's like creating a whole new industry, a space-based equivalent of the auto repair shop.
It's mind-boggling to think about the possibilities. We're not just exploring space anymore. We're learning how to live and work there, how to take care of our technological creations, and how to ensure that they continue to serve us for generations to come. It's a whole new chapter in the human story.
I love that perspective, and it's important to remember that this is still just the beginning. We're only scratching the surface of what's possible when it comes to space telescope servicing. Who knows what incredible innovations and discoveries lie ahead?
Yeah, it's definitely a field with a bright future. But before we get too carried away with dreams of interstellar repair shops, let's bring it back down to Earth, or at least to Earth orbit. We've been focusing on telescopes at L2, but what about the ones closer to home?
That's a great point. There are plenty of telescopes orbiting Earth that could benefit from servicing and upgrades. In fact, some of the technologies we've been discussing, like safe proximity operations and robotic repairs, could be even more easily applied to telescopes in Earth orbit.
So this research has implications for the entire fleet of space telescopes, whether they're a million miles away or just a few hundred.
Exactly. And it's not just about fixing things that are broken. Servicing missions could also be used to upgrade existing telescopes with new instruments and technologies, extending their capabilities and allowing them to make even more groundbreaking discoveries.
It's like giving these telescopes a midlife upgrade, allowing them to stay at the forefront of scientific research for years to come.
You got it. And as technology continues to advance, the possibilities for upgrading and enhancing these telescopes are virtually limitless.
This This deep dive is really opening my eyes to the incredible potential of space telescope servicing. It's like we're on the cusp of a new era of space exploration where our scientific instruments can evolve and adapt to keep pace with our growing curiosity about the universe.
I share your enthusiasm,
Yeah.
and what's really inspiring is that this new era is being shaped by the ingenuity and passion of scientists and engineers from all over the world.
People who are driven by a deep desire to explore, to understand, and to push the boundaries of human knowledge. It's truly a collaborative effort that transcends national borders and unites us in a common goal.
I couldn't have said it better myself. It's a reminder that when we work together, when we combine our talents and resources, we can achieve extraordinary things.
Well said. And on that note, I think it's time to move on to the final part of our deep dive. We've covered a lot of ground, but there's one more crucial aspect we need to explore, the ethical considerations of space telescope servicing.
That's an excellent point. As with any powerful technology, there are ethical implications we need to consider carefully.
So stay tuned, folks, as we delve into this important topic and wrap up our exploration of this fascinating field. We've been talking about all the amazing possibilities, right, of servicing space telescopes, extending their lifespans, even upgrading them with new technology. You know, it's clear that we're entering this new era of space exploration. But as with any powerful technology, there are ethical considerations to keep in mind. What are some of the questions we should be asking ourselves as we venture further down this path?
Yeah, that's a crucial point. Just because we can do something, doesn't necessarily mean we should. One of the biggest concerns is the potential for space debris. As we send more and more servicing missions into space, the risk of collisions and creating more debris, increases. And that debris can pose a threat to other satellites and even future missions.
That's a sobering thought. It sounds like we need to be very, very careful about how we approach these servicing missions to minimize the risk of creating more space junk. What are some of the ways we can do that?
Well, researchers are already working on solutions. One idea is to design servicing spacecraft that can deorbit themselves, or capture and remove debris after they've completed their mission. Another is to develop technologies that can repair or refuel telescopes without leaving any parts behind.
So it's about designing these missions with sustainability in mind from the very beginning. It's like the leave no trace principle, but for space exploration.
Exactly, and it's not just about physical debris. There's also the issue of light pollution. As we build larger and more powerful telescopes, they can potentially interfere with astronomical observations from Earth.
That's an interesting point. I hadn't thought about that before. Yeah. So it's not just about what we leave behind in space, but also about the impact our activities can have on our ability to observe the universe from down here on Earth.
Precisely. And as we develop new technologies for space telescope servicing, we need to carefully consider their potential impact on ground-based astronomy. It's about finding a balance between pushing the boundaries of space exploration and preserving our ability to study the cosmos from our own planet.
These are definitely important ethical questions to consider. It seems like the key is to proceed with caution and to engage in open and transparent discussions about the potential risks and benefits of these technologies.
I completely agree, and it's not just up to scientists and engineers to make these decisions. It's a conversation that needs to involve policymakers, ethicists, and the public at large. We all have a stake in shaping the future of space exploration.
That's a great point. It's not just about the technical feasibility of these missions, but also about the values and principles that guide our exploration of the cosmos.
This deep dive has been fascinating. We've explored the mind-boggling challenges of servicing telescopes millions of miles away, the ingenious solutions being developed by researchers, and the ethical considerations we need to keep in mind.
It's been an incredible journey, and it's left me feeling both excited and humbled. Excited about the possibilities that lie ahead, and humbled by the vastness of the universe and the responsibility we have to to explore it ethically and sustainably.
I couldn't have said it better myself.
Yeah.
As we continue to push the boundaries of space exploration, let's remember that it's not just about what we discover out there, but also about how those discoveries shape our understanding of ourselves and our place in the cosmos.
And on that note, I think we've reached the end of our deep dive into the world of space telescope servicing. It's been an incredible journey, and I hope you've enjoyed it as much as we have.
It's been a pleasure sharing these insights with you, and I hope we've sparked your curiosity about the future of space exploration.
And who knows, maybe one of you listening will be the one to invent the next groundbreaking technology that allows us to keep our eyes on the cosmos for centuries to come.
Now that would be a truly inspiring legacy.